Hello my dear friends, welcome to the subject of statistics for the class 12th English medium. The first part, the third chapter, that is linear regression, and this will be the last tutorial for this chapter. We are going to end this chapter in this tutorial. Last time the content we studied, first one was some illustrations based on the coefficient of determination and illustrations based on the short formula kind of methods. This time we will study miscellaneous illustrations and complete the chapter. We will start with illustration 18. In illustration 18, the first question given, the regression line is available. We have a observation 16 and 108. Here 16 is the x, 108 is the y, and we have to find the error for estimating y when x is 16. Now whenever we are supposed to calculate error, we must have the original observation and the estimated observation. As you can see here, the value of x is 16, and when x is 16, the observation for y is 108 as the information is available. What we are going to do is we will put x is equal to 16 in the y cap formula. That way we will get the estimate of the y when x is 16. So 3.5 into 16 will be 56 plus 50 will be y cap is equal to 106. Now as you can see, the observed value was 108 while estimated value is 106. So naturally error, which is y minus y cap, will be 108 minus 106, that is E is equal to 2. So my dear friends, the error in estimating y for x is equal to 16 is 2. It is very simple sum. This kind of sum we have already done. Very easy, only 2 mark. The second sum of the same illustration, one observation is 1030, which is used for fitting the line. Error for estimating y when x is equal to 10. That just means that we have to find the error just like the last sum. We will put x is equal to 10 into equation 22 plus 0.8 x. When we put x is equal to 10, we get 22 plus 8. The answer here is 30. Once we get the y cap, and the original answer for x is 30 and the estimate is also 30, that means y minus y cap will be the same thing, 30 minus 30. The error here is 0. Now if you recall the regression line which we drew in the very initial basis, we said that when the original value is on the line itself, the error is 0. If the original value is above the line, the error is positive, and when original value is below the line, the error is negative. Right now the error in estimating y for x is equal to 10 is 0. That means we can say that the value is 0, so 1030 lines on the exact regression line. So the regression line and the observed value and the estimated value are the same, so point is itself on the straight line. It is not above, not below, but on the exact line. Illustration 19. First question here is the regression line is given 25 plus 3x, covariance is given 48, and we have to find the standard deviation of sx. That's the first question. Second question, we have to find r square when standard deviation for y is 15. So what we are going to do, we will compare the regression line with our formula. Regression line given is 25 plus 3x and our formula is a plus bx. So if we compare these two things, a will be 25 and b will be 3. As you can see the similarity here, a will be 25 and b will be 3. So regression coefficient b is 3 and covariance xy 48 is given. So when we put it into formula, the formula is b is equal to covariance xy upon sx square. B is available, covariance xy is available, and sx is we are supposed to find. We will put the values in this equation. B is 3, covariance xy is 48. When we change the side, sx square will be equal to 16, that is 48 upon 3, and when we find the root, sx will be 4. So that's the answer for the first question, that the standard deviation for x is 4. We were supposed to find the standard deviation x first. Now Standard deviation of y is given, that is sy, that is 15. We have standard deviation of x, that is 4. So sx, sy is available. We have to find the coefficient of determination, that is r square. The formula which we are going to use here is the formula for simple correlation, that is covariance xy upon sx into sy. This is the basic formula from the second chapter, and the whole square. So solid simple 48 upon 4 into 15, that is 0.8, whole square is 0.64. So here the coefficient of determination is 0.64, and that's the end of this sum. The second sum for the same illustration, the regression line in the above equation, how many units should be increased in the value of x to increase approximately 15 units in the value of y. Now as you can see, the regression line was 25 plus 3x, and the regression coefficient b is 3. So that indicates that if the value of x is increased by 1 unit, the value of y is increased by 3 units. Once again, b is 3. That means if I take x as 1, 1 into 3, y will be 3. If I take x as 2, 3 into 2, y will be 6. That means an increase of 3 units. So if I increase x by 1 unit, the value of y will increase by 3 units. So if the value of y is to be increased by 15 units, then I should take x as 15 upon 3 is equal to 5 units. So if I take 1 unit of x, I will get 3 units of y. If I want to get 15 units of y, I will divide it by 3 and I should get 5 units of x. That's how we do this sum. This is a simple sum of statements. You just have to write a statement here. B means when x is increased by 1 unit, y will be increased by the number of b units. So I just have to take the reverse value, that if I am increasing y with certain units, I will divide it with the b to get the units of x. So I want y to be increased by 15 units, b is 3, so 15 upon 3 is equal to units for x, that is 5. Illustration 20, the first question, regression line is given, x upon 2 plus 5, sy is 2, sx is given. We have to find the coefficient of determination. Now first of all, we have to check what is a and b. When we compare the regression lines, that is x upon 2 plus 5, or we can write 1 upon 2 into x plus 5 and compare it with a plus bx. Here a, that is the single value, that is 5, so a is 5. Bx, that is something which is multiplied with x, so here we have multiplied x with 1 upon 2, so we get b is equal to 1 upon 2. B is not 5. Some students make a mistake that the first value is a and second value is b. They are wrong. The value which is multiplied with x is b, and the value which is a standalone is a. Here 1 upon 2 is multiplied with x, so b is 1 upon 2. What we are supposed to see here, that sy is to sx is 5 is to 8, and therefore sy upon sx can be taken as 5 upon 8. We are supposed to find the coefficient of determination, but before finding coefficient of determination, we need coefficient of correlation, that is r, because determination is the r square. How can we get r? So we should remember this formula, that b is equal to r into sy upon sx. When you remember these formulas, no, it becomes so easy to solve the sum. If you have forgotten the formulas, you just get stuck at what to do, what not to do. Just try to remember the formulas properly, it will be easier. B is equal to r into sy upon sx. So when you put the value of b and sy upon sx, you get something like this. Change the sides of 5 and 8. You will get 8 into multiplication and 5 into division. That is r is equal to 1 upon 2 into 8 upon 5. You make the inverse when you change the sides. So just multiply these values, you get r is equal to 0.8. And when you get r is equal to 0.8, the coefficient of determination is just the square of r, that is 0.8 square, 0.64. So the value of coefficient of determination is 0.64. All of these sums are weighted just 2 marks in the boards, but all of them are quite complicated. They have various methods. So you know, my dear friends, you can solve 5 mark sums the most easily. Next difficulty comes to the 3 mark sum, and the most difficult sums are this 1 and 2 marks. They weight less, they take less time, but they are more complicated. They use up your brain more. The second question of the 20th illustration, we have the regression line, but wow, we have a different kind of a regression line here. We have 4x plus 5y minus 65 is equal to 0, and we have to find the regression coefficient b. Here we can't find any A's, we can't find any B's right now. But what we can do here is we can convert this into our standard format. How? Our standard format, as you can remember, is y is equal to a plus bx. That means on the left side of the equal to, we need just y, and everything else will be transferred to the right side of the equal to. As you can see here, 4x and negative 65 we will transfer to the right side of the 0, right side of the equal to. That way negative 5 will become positive 5 and 4x will become negative 4x. So 5y is equal to 65 minus 4x is the first term. Now on the left side of the equation, we just need y, we don't need the 5 figure. So what we are going to do, we are going to change the side of that 5 to the opposite side in the division, something like this, that is 65 minus 4x upon 5. Now we know that we can split the divisions when there is addition or subtraction, so we are going to take it like this: 65 upon 5 minus 4x upon 5. We can naturally, we know that when denominators are same, we can add or deduct the numerators. Same way, when there is a single denominator and the numerator has addition or subtraction, we can split them. Now here we have 65 upon 5 and 4x upon 5. When we separate them, we get something like this: 65 upon 5 is 13 and 4x upon 5, that is 4 upon 5 is 0.8. As you can see, our original equation is a plus bx. Here a is 13 and plus is changed into minus. That means our b must be a negative value. That's why we get b is equal to negative 0.8. So b is 0.8 and the value is negative, so we take it as negative 0.8. I will repeat it. Now, before we move forward to the 21st illustration, we should remember one rule which will help us in solving that illustration. Rule number 1: if u is just x minus a and v is just y minus b, then byx is equal to bvu. Actually, this rule I already explained beforehand while discussing the shortcut formula, but I am recalling it once again because we are going to use this. Here it means that there is no division or multiplication in either u or v. That's why byx will be bvu. There will not be any problem, as regression coefficient is independent from the change of origin. That means when we add or subtract something, we are not having any difference. But if we deduct, divide or multiply something, there will be a change. When we divide u with cx and divide v with cy, we change the answer. That's why if we want to find byx, we have to multiply bvu with cy upon cx. So that means when there is only addition or subtraction, byx, that is the regression coefficient of yx, and regression coefficient of vu are same. But when there is a division, that is cy and cx, it changes. So if we want to find regression coefficient of yx, we need to multiply regression coefficient of vu with cy upon cx. This rule will be very important for solving the next illustration. The next illustration is illustration 21. The first question of this, there are actually 4 questions here. The first question here is that if byx is 0.85, see guys, byx is directly given. U is x minus 15 and v is y minus 20. No division here. We have to find the value of bvu. As we know, when yx is one in the same, then bvu is byx itself. So answer is 0.85. We get the direct answer. There is no difference here, as there is no division. The answer is same. The second question here, there is a division. So what we are going to do, here u is x minus 5 upon 3, v is y minus 8 upon 5. So cx is 3 and cy is 5. The byx is 0.9 and we have to find the value of bvu. We will write the formula: byx is bvu into cy upon cx. So just swap the formula, just change the formula. What we are going to do, we are going to change the side of cy upon cx. So cy goes into division, cx goes into multiplication. That way you will get bvu is equal to cyx into cx upon cy. What we did here, we changed cy to the opposite side, that is in the division of byx, and cx in the multiplication of byx. So just put the available values. Byx is 0.9, cx is 3, cy is 5. When you solve this equation, you get 0.54. So BVU for this is 0.54. Next, you have something like this. If u is 10, that is into x minus 4.5, and v is y minus 50 upon 10, we have to find byx, bvu when byx is 0.25. As you can see here, u is multiplied with 10. When we multiply with 10, we say that we divide it with its inverse. Its inverse is 1 upon 10, that is 0.1. So when we multiply with 10, we divide with 0.1. So cx here is 0.1 and cy here is 10. And what we are going to do, we are going to use the same thing. bvu will be byx into cx upon cy. We will put the values here. Byx is 0.25, cx is 1 upon 10, or you can write 0.1, doesn't matter. Divide by cy, that is 10. When you solve this, you get 0.0025. So BVU for this question will be 0.0025. You just have to remember this formula, that is BVU is equal to Byx into Cx upon Cy. Just remember this formula, simple. The last one, both of them we have multiplied. The u is 5 multiplied with 5, and we have multiplied with 2. The byx is 1.6. We have to find the bvu. As you can see here, we will take the inverse. So cx will be 1 upon 5 and cy will be 1 upon 2. So cx 1 upon 5, cy 1 upon 2, that we will put in the equation here. Byx into cx upon cy 1 upon 6 into 1 upon 5 upon 1 upon 2. As you can see, 1 upon 5 will go to division and 2 will come into multiplication. This is the inverse rule. So 1 upon 6 into 2 upon 5 is equal to 0.64. So your answer for BVU will be 0.64. Now this kind of question is usually asked for 1 mark or in MCQ. So all these 4 kind of question, there is a high chance that you will get at least one question of this kind in either section A or in section B. There is a high chance that you will get it. So if you want, you can just rewind this video again to check these 4 questions out. What you need to remember, that whenever there is only addition or subtraction, you don't change the answer. But when there is a multiplication or division, you have to change your answer. And the formula which you are going to use for this is BVU is equal to Byx into Cx upon Cy. This is the formula which you have to use for this particular solution. So with this, my dear friends, we end our chapter. In this particular tutorial, we studied the short sums based on coefficient of determination, and then we solved equations to find regression coefficient, and also we found the shortcut regression coefficient based on the given values. So with this, we are ending the chapter number 3, linear regression. What we are going to study next time is that we are going to start with the 4th chapter, that is the time series, and that's the last chapter of the first part of statistics, my dear friends. So soon we are going to complete this chapter. So till then, stay home, stay safe, and see you soon, my dear students.